All right, guys, here is part 2 of this week's video. I have downloaded an app that turns my phone into a document camera, so hopefully this will work a little bit better. We are moving right along with factoring, okay, and we're going to work on factoring this time trinomials. But notice, normally when we factor trinomials, we have our square term, okay? Also, the camera lags a little bit, so I'm sorry if my voice moves faster than what I'm pointing to. But notice this is to the 4th power and not squared. So what we want to do is find out how to turn that into a squared. So when we factor quartic equations like this, it's going to be the exact same thing as factoring quadratics in trinomials. However, watch what happens here. Okay, we still want to know what multiplies to give us a times c, which is negative 24. Okay, and what adds to give us b, which is 2. So what two numbers multiply to give us negative 24, but add to give us 2? Okay, if you said 6 and negative 4, that's correct. Okay, so what we want to do here is we want to factor this into our two binomials, okay? But instead of doing n and n, we're going to do n squared. Okay, and then it's going to be plus 6 minus 4. Okay, and this is how we will solve this quadratic. So notice how it factors. Okay, instead of n plus 6, n minus 4, since it's raised to the 4th power, okay, we now have n squared and n squared rather than n and n. All right, so when we go to solve these, now we're going to solve by taking square roots. Actually, rewind, we are not going to solve. We're going to save solving for next week. Okay, so let's just see if we can factor anything else. Can we factor n squared plus 6 anymore? Nope, that's how it factors, so that will stay n squared plus 6. What about n squared minus 4? Can we factor that anymore? Okay, and the answer to that is yes. That becomes the difference of two perfect squares. But it seems that my dock camera has froze, so let me pause and let it catch up. I'm going to rewrite n squared plus 6. Since that is going to be a factor, that won't factor anymore. And then n squared minus 4 becomes n plus 2, n minus 2. Remember, we take the square root of each. Okay, square root of n squared is n, and the square root of 4 is 2. And that will be our answer. All right, let's look at number 16. Okay, number 16, we see we have a cubic. Is there anything we can factor out here? Is there anything we can factor out? Okay, it looks like each term has a w in common, so that's going to be our GCF. So if we factor out a w, inside we're going to be left with w squared plus w minus 20. Now notice this is a quadratic, so we can factor this the normal way. It's not a quartic like number 15 was. So we're going to see what multiplies to give us negative 20, and what adds to give us 1. Okay, so what two numbers multiply to give us negative 20 and add to give us 1? That will be 5 and negative 4. So that's how that quadratic will factor. So our W stays on the outside. That is our GCF. And then W squared plus W minus 20 will factor into W plus 5, W minus 4. Okay. All right, number 17, that's another cubic, so we want to see if we can factor out a GCF first. And notice our GCF, what does each term have in common? Okay, well, each term has a 2a in common, so we will factor that out first. And inside, we're going to be left with a squared plus, and then we have to do 38a squared divided by 2a, so that's going to be 19a plus 34. Okay, and then we have to look, can we factor that quadratic anymore? So we want to ask ourselves what multiplies to give us 34 and what adds to give us 19. So what two numbers multiply to give us 34 and add to give us 19? And that would be 17 and 2. So that middle term, or I'm sorry, not that middle term, but that quadratic is going to factor into 2a. Make sure that GCF stays on the outside. And then it's going to be a plus 17 and a plus 2. All right, number 18, you'll notice this is a quintic trinomial, so we're going to have to factor it like a quartic. Okay, now remember, it's the same way, except when we factor it, we get these squared terms, okay, like right here, n squared, okay, we get these squared terms instead of just our linear term, which is what we have here, like a. Okay, so first thing we're going to look for is the GCF. What is the GCF here? If you notice, the GCF is going to be x. So let's go ahead and factor that out first. And if we factor out an x from every term, we're left with x to the 4th minus 24x squared minus 25. You notice this is a quartic, so we're going to want to factor it in such a way that when we multiply it back through, we will get x to the 4th instead of x squared. Okay, so again, it's going to be the exact same thing, except instead of x and x, we're going to have x squared and x squared. So we want to ask ourselves what multiplies to give us a times c, which is negative 25, and what adds to give us negative 24. Okay, what multiplies to give us negative 25, adds to give us negative 24. That is going to be negative 25 and 1. Negative 25 times 1 is negative 25. Negative 25 plus 1 is negative 24. Okay, so make sure you keep that GCF x on the outside. And then your two parentheses, again, you're going to have those squared terms. So instead of x and x, it's going to be x squared and x squared. Okay, then we have a negative 25 and plus 1. Okay, notice the difference here. When we have a quadratic versus a quartic, okay, when we factor a quadratic, it becomes a and a here. And when we factor our quartic, it becomes x squared and x squared. All right, so can we factor any more? Is there any factor here that will factor again? Okay. And the answer is yes, it is x squared minus 25. So we're going to bring down our x, but x squared minus 25, that's the difference of two perfect squares. So we take the square root of each, that's x plus 5, x minus 5. Okay, that's what this factors into. And then x squared plus 1, that is the sum, not the difference of two perfect squares, so that will not factor anymore. And that is completely factored now. All right, number 19 is going to be a little bit tricky because this is the case where a is greater than 1. Okay, these are the ones you guys do not like because they do take quite a bit more work. So what we're looking for here, remember we want to find what multiplies to give us a times c. In this case, we are looking at 3 times negative 5, which is negative 15. And what adds to give us our b term, which is positive 14. Okay, so what multiplies to give us negative 15 adds to give us 14. That will be 15 and negative 1. So when a is not 1, this is where we have to split up our middle term. Now you have to be careful here because it's going to be x squared instead of x's. Okay, so we're going to take this middle term and break this up into, we're going to carry down our 3x to the 4th. And then we're splitting our middle term up into 15x squared minus 1x squared, and then bring down your minus 5. Okay, so all we did here was we took that middle term and broke it up into 2. So now I'm going to group the first two, and I'm going to group the second two, and then I'm going to find the GCF between each of them. So when I'm looking for the GCF of 3x to the 4th and 15x squared, okay, it's going to be 3x. So I factor, or I'm sorry, 3x squared. So if I factor out a 3x squared, I'm left with x squared plus 5. And then looking at my second term, I have a negative 1x squared and a negative 5. I'm just going to factor out a negative 1 there. So I'm left with x squared plus 5. Okay, notice how we have x squared plus 5 and x squared plus 5 that match. So we'll factor those out, x squared plus 5. And what are we left with?